we will be having our daily pricing. The data lakehouse container is the one we are focusing it. That code run through. We have got in the branch layer, we have got the daily pricing data. This is the year worth of the data. That is the one data set. And the geocoding data, this is the one that we are trying to extract now. This is the one bringing the population and latitude and longitude information. And we already developed the code to convert that branch layer data in the complex JSON format into the flattened JSON format. This is the one we worked on the last week, and we can run this code for all of the market names. It's only stored for the market name, only one market name last week, but now if the other code will run through, it will bring all of the market names here, and all of the market name data will be flattened it. Now the final task for building the gold layer is we need to join the branch layer daily pricing data that is in the Parquet format, okay, and the silver layer geocoding that is in the JSON format. It is again very straightforward. We have seen the how to join the two data frames last week. If you look at the silver layer population for the geocoding transform, we did the join there for flattening the complex data type here. Individually we extracting the column names and then we join together. It is going to be the same syntax, okay. You need to read your daily pricing data as a one of the data frame as a from the Parquet format that's coming from branch layer. The another one, you need to read your silver layer geocoding data as a another data frame, and the common column name between both of those data frames is market name. You need to join it using the market name. So when you specifying the join column name, you need to specify that one, and then you will write that into the gold layer. That is can be the final gold layer output can be used for the price predictions in the future. We specifically producing it for feeding the AI algorithm with additional data on top of the pricing data that will impact the price of the products. One more thing is weather data. I have given that as a exercise. The weather data also follow the similar format for ingesting in the bronze layer and similar format in the silver layer as well. And originally when we combine multiple data together, we need to combine bronze layer daily pricing and silver layer geolocation and the silver layer weather data. But weather data I am giving it as a exercise so that little you will start to think about it, how to read the data and how to transform the data. It is exact existing notebook format, only your source data folder and little changes in the format. Hopefully you could be able to do that one. And the gold layer is combining bronze layer and silver layer. It is not necessary that all of the data need to be in the silver layer. If you got some intermediate transformations need to be done, then only it will be in the silver layer. While producing the gold layer, you can join your bronze layer data with silver layer data and produce the final gold layer. That is the one of the tasks we can do it. I can't see there is too much complex in doing that one. Hopefully this will run through fine, but we can start to develop the code for that one so that we get the idea of how to joining that one, okay. I'm going to use some of the path names that we loaded in the silver layer for the geolocation data. So I'm going to working labs and I'm going to create them ingest gold layer data, okay. We'll be creating the new folder for ingesting that into the gold layer. Create notebook. Okay, so one of the source for loading the gold layer is this geocoding folder. This is where we have converted our I think I need to open this in the multiple windows. That will make sense, I think. Open link in new tab, open link in new tab, otherwise I'll be convert. Okay, so our main source data is existing in the bronze layer daily pricing data. This is the one of the code we need to do it. So I copy paste these variables and I will change the path quickly, because instead of typing it will take little time. So the first source data we have got is bronze layer daily pricing folder. So it is existing in the data lake house and the path is bronze / daily pricing. Probably I copy it so that there won't be any spelling mistakes. Okay, this is the one of our source data. This is existing in the Parquet format. The another data is existing in the silver layer, where we have transformed our geocoding data in the flattened format. This is the data. So already I think I copied that path properly, silver layer geocoding. So both of them is our source folder paths. We need to create the data frame for each of them. So the first one we are going to create for the Parquet format one. This syntax probably Parquet of bronze daily pricing folder, and we try to display the data so that we make sure that okay, probably here I can clarify what Amar asked a little more one time. This display is trying to collect all of the data from this data frame, Amar, and trying to display it. Instead of saying display, if I do the collect here, it also does the same task. Without the display, it will display all of the values in the data frame. So probably it's all linked actually, so that you know actually it's collecting all of the values in the data frame and display it. It won't display the data frame structure. This time it will display the actual values. It's collecting entire data, that's why it's taking a little while. Okay, we start to write the code for silver layer geocoding data frame as well. Data frame equal to, again slowly this might be memorizing for you what Spark library we need to use for reading it, what are the options we need to use as well, and you can refer back our some of our previous code as well. It won't come very quickly. Okay, it's very clearly giving it now, Amar, actually. In fact, this is the original way of storing the data inside it. Okay, for each individual row, it is using the internal data type called row. Okay, and inside the row, each of the column values are stored. This is how the data frame values are stored actually internally. But this row is gone out of our scope. We don't refer anymore. We directly referring the individual columns to extract the individual column values. Yeah, that's what collect does actually. So now I will display the silver layer geocoding data frame as well. So this is the value we got it, the population value and the latitude and longitude information. This is all we need from this data set name. Now we are going to join these two data frames. Okay, just quickly notice that we are joining one data set in Parquet format, another one in JSON format. This is all for us to represent the source data set. Once it converted into the data frame, there is nothing a difference with respect to the Spark. It uses internal libraries to read this data, but the data sets in the different formats can be joined together directly without having any problem at all. Okay, so this is daily pricing DF is our main data frame. So dot join, the other data frame is silver geocoding data frame. I will refer the join syntax again. I also little not memorizing everything actually. So one data frame dot column equal to the another data frame dot column. So branch daily pricing df dot, from here I am going to join the value of this market name equal to this silver geocoding df dot, here also we have got the market name. So this will be the our gold pricing data frame equal to this one. Now all of the column values probably will come, but we know how to select the specific column names before writing into the gold layer.